I've had it with these stupid leaking lights. Last fall I discovered leaks behind these lights, so much so that it kind of delaminated a little bit of the plywood behind it. Now in this coach the plywood is only in the general vicinity of the lights, and it's used as a backing material to screw the lights down into. But still you can delaminate the area and it can still do some serious damage. Well, last year I pulled the lights, I epoxied inside of the voids so that the damage would no longer occur even if it got wet, and I sealed them up as best as I could. I also bought new gaskets from the manufacturer of the lights so that would help, I hoped, but it didn't, because 6 months later we're right back to where we were. We got leaking lights again. And I know at least 5 other RV owners that have these type of lights on their motorhomes that have had the same issue. Now these lights are very popular with motorhomes. They're found on Thor's, Coachman, Forest River, Winnebago, and probably some others. And they're just cheap. They just don't work, don't last. So if you have a pair of lights like this, I highly recommend that you look into whether or not that they're leaking or not. And you may end up having to do some work on these things. I'm going to replace these lights with these nice Bargeman lights. And the main difference is these lights seal by screwing directly onto the back, where these lights have a flange which you can permanently seal, and then when you replace the bulbs, these lenses themselves come out from the front, and the lenses are recessed in here so that they don't get water in them. Last year when I waterproofed this, I actually put some silicone sealant in this channel to waterproof where these wires came in, but in preparation to replace this light, I pulled all the silicone out, which actually pulled out some of the epoxy back here, so I got some raw wood that I'm going to have to re-epoxy. Now, as luck would have it, this Bargeman light is within about a 1/16 of an inch, both in the vertical and the horizontal, so these should fit fairly nice. The only real problem is the width here is a little bit more than what we have here, so what I'm going to have to do is figure out how to cut around here a little bit to slightly enlarge this opening. So I'm going to explore how easy that's going to do before I make a commitment to get to the point of no return, because obviously I don't want to make the situation worse by bungling up the project. So the next step is going to be to see if indeed we can actually cut this out without any issues. What I'm going to use is this bit set by Freud, and it's a ball bearing bit set with different ball bearings. So what I can actually do is take one of these ball bearings that is the right depth and put it in the router and run along here, and I can extend the slot, and then I'll take another bit with a ball bearing on the top and then run it in here on the first cut and make it flush to the bottom here. So between the two bits I'll always have a guide around here when I do the cut, so I won't be zipping the router up somewhere and just making a big gouge through it. So I think I can do that, and in fact I can do that here in these corners and still be able to button it back up using this one if I have to. Here's a visualization. The router bit on the left has a ball bearing on the bottom, and it is smaller diameter than the bit itself. The ball bearing will run across the surface of the edge and allow me to cut a notch as shown. Then with the second router bit, the ball bearing on the top, I will run that ball bearing in the notch that I just cut, and it will allow me to clear out the rest of the cut, so I'll have a flush cut all the way to the bottom. Now the reason to use ball bearings with these router bits is that you can control the cut and it doesn't allow the router to get away from you, because it's always supported by the workpiece itself. Okay, I've got that router bit in my DeWalt router, and I'm going to try to just first of all get this wider. So here goes. Okay, I'm going to do that on all 4 corners and then see if it's wide enough. At this point, using that bit, I've cut a slot in here. Of course, that's about as far as I can go. Now I'm going to use this bottoming bit
to come in here and go deeper. So that's the next step. So now I've gone about as deep as I dare here. But now what I got to do really is I got to cut out these corners a little bit. And I don't want to do that anymore with a router, so I'm going to use one of these multi-tools to do that. I can't go any further in doing the test fit for the new lights until I get rid of this light. So what I did is I got a pack of these wire markers. And this is probably overkill, especially for somebody that is pretty good at doing electrical work. But I marked each one of these wires in 2 places. So here I got a 3 and here I got a 3, and I'm going to snip it between these 2. So I can always find out where they went it to the original light. And I recommend doing this if you're not really accomplished at doing electrical work, because once you mark it, you can always go back. And if you cut them without marking them, then you know you're kind of on your memory and your knowledge. So if in doubt, mark them. Well, I have to do some final trimming, and lo and behold, this thing is off a little bit. Imagine that. So I took a level and leveled it to the edge of the trailer here, and then marked off kind of with blue tape where the high spots are. And so I'm just going to kind of try to trim around that a little bit. Well, now I got this cut out just about where it'll fit. So like I did before last fall, when I first figured out the problem, I need to paint this on the inside with some epoxy so I can waterproof it. I'm using 5-minute epoxy to do this because I don't really need it to be structural at all. I just need it to be waterproof. So basically I'm just going to go over the spots that I hit with a router and the multi-tool, like that, and then we'll let it dry. I also need to seal these holes. I'm going to mix some of this 410 microlight fairing filler in with the epoxy and put it in one of these syringes, and it kind of makes it like peanut butter. And then I'll just put it in each one of these holes and fill the holes up, and when it dries, it'll be all protected. There's a trick to drilling holes in fiberglass, and I've got to drill 2 holes here for the new light. What you do to keep from cracking it is reverse it and go through the fiberglass in reverse just enough to clear through the gel coat. Then you can put it forward and drill the rest of the way through. The method that I'm going to use, though, is I got a set of these nice plastic drill bits, and they're a much sharper point than a standard drill bit, and this will keep from cracking the plastic. Now these are fairly expensive. They're about $50 a set. So if you don't have a set of these, then the reverse drill trick works quite nice. So now I got the holes drilled and I'm ready to put this on. What I'm going to do is I have a syringe filled with silicone sealant, and I'm going to put that in these holes before I put the screws in. And then I'm going to put a bead of silicone around here, and then we'll button it all up. Well, my favorite method of splicing is soldering, and that's what I'm doing here. And when I'm done with it, I have some marine grade heat shrink that's actually an adhesive inside of the heat shrink, and that will go over the wire and it will make the wire waterproof. There we go. Well, they at least followed the color code, with white being neutral, black being tail light, green being left turn signal, because this is left light, and red is the only one left, and I'm going to assume that's backup. I didn't test that, but it's the only function it can be. On the back of the light, they have white, black, and green for those functions, plus another black for the backup. Okay, so now we've got the wiring done. They're all heat shrinked, and I'm really glad I did this project because I actually found where some of these wires were starting to oxidize, and the only reason they oxidized is because they got wet. So we got them all protected now. So now I got 2 holes drilled, just test holes, I guess you could call it, and I'm going to button it up with the 2 holes, test it out, and if it works, I'll drill the rest of the holes, and then we'll get this thing buttoned up. What can I say? This is just another indicative part of how messed up the RV industry is. Guess what? These lights are backwards. The brake light is on the turn signal, and the turn signal is on the brake. And the reason that's important, because in these light bulbs, one is brighter than the other. So when the taillights are on, you can't see the turn signals because they're not bright enough. So what I got to do is go in and reverse wire from green to green and black to black. I go black to green and black to green. So it's always something with the RV industry. Okay, so now I've got it reversed again, and you notice green goes to black, black goes to green, and I had to do that to get this to work right. So either this manufacturer is goofed up, the manufacturer of the original lights, which is a different manufacturer, is goofed up, or the manufacturer of the coach is goofed up. One of the three don't know green from black wires, I guess. There we go, we're all done with the project. I siliconed the entire back side of this, so it should never ever leak, because you can get to these open this way by taking these two screws off here. That's how you change the lights. So you see, this always stays on, and there's actually a lip around here, which I was surprised there's no gasket, but Bargeman said they don't have any trouble with leaks. And if it did leak, I suppose you could get an O-ring kit and put an O-ring in there. But I don't think we're going to have any leak problems, because the lens gets sandwiched in there. So there you have it. One more project done.